Welcome to integration with respect to time. So integration of acceleration with respect to time gives us the velocity, because remember, acceleration is the second derivative and velocity is the first derivative. And if we integrate velocity, we get displacement. The integration is like finding primitives, so remember to include the plus c. And in these cases, you will generally be given information to find the c value. Terms you need to know, so a reminder about what initially stands for, stationary, origin, and what constant acceleration and velocity stand for. So example 1, particles moving with velocity v equals 6t squared minus 12t, given that initially the particle is 3 meters to the left of the origin. We're going to find the displacement first and then we'll answer the rest of the questions. So let's break this down in the question. So initially t equals 0, 3 meters to the left of the origin, that means that x equals minus 3. So the displacement is minus 3. So the displacement function, if we integrate 6t squared minus 12t, we get x equals 2t cubed minus 6t squared plus c. Using the information we just had, 3 meters to the left, x is minus 3, and t is 0, we substitute those in and we get a constant of minus 3. That gives us a displacement of 2t cubed minus 6t squared minus 3. So the particle returns to 3 meters to the left after 3 seconds. Well, reason I've got two equations here is I'm going to show you both ways. So one way is use the fact that it's after 3 seconds and let's show that it gets back to 3 meters to the left. So show that it gets back to x equals minus 3. So substituting 3 in, you get 2 lots of 3 cubed minus 6 lots of 3 squared minus the 3, and you get x equals minus 3. That's proven that it returns. What about 3 meters to the left? Well, that's when x equals minus 3. So using quadratics, we make it equal to 0, take out the common factor of 2t squared, and that means that t equals 0 and t equals 3. So it returns after 3 seconds. When is the acceleration 0? Well, acceleration is the derivative of the velocity. So if you differentiate that, you get 12t minus 12. When is the acceleration 0? Sub a equals 0 and at t equals 1. So the acceleration is 0 after 1 second. Here's our second example using exponentials. So we're going to find, you're given the acceleration is a equals e to the minus t, and you're given that the particle is initially stationary at the origin. So there's 3 lots of information in those words there. Initially, stationary, at the origin. Initially, 0, stationary, v equals 0, origin, x equals 0. So to find the velocity, we integrate acceleration and put a plus c. So this is our first constant that we're going to find. So when you integrate e to the minus t, you get minus e to the minus t plus the constant. So we know that the velocity is 0 when t equals 0. So subbing in v equals 0 when t equals 0, e to the 0 is 1, so you get 0 equals minus 1 plus c, gives you a c equals 1 and v equals minus e to the minus t plus 1. Using the second part, so we're going to integrate the velocity, that gets us the displacement, and you get x equals e to the minus t plus t, so 1 integrates to t, plus our new constant. Substituting t equals 0 when x equals 0, remembering that e to the 0 is 1 again, you get our new constant of minus 1, giving our displacement formula x equals e to the minus t plus t minus 1. Now we're going to use those equations to find the other information or answer the rest of the questions. The acceleration function, a equals e to the minus t, sketch the velocity function and describe what happens as the velocity as time goes on. Well, that is the velocity function. So that was minus e to the minus t. which is the velocity is initially at 0 and increases as velocity approaches 1. So remember, the velocity was v equals minus e to the minus t plus 1. So therefore it approaches 1. So that's how we actually sketch our velocity function and how we describe it. Thank you.